Okay, this is the last of the 3 sections for Appendix C. It's a review of polynomials. And if you want to look in your book, this is on page A18. Let's go back up to some vocabulary. We have a monomial. A monomial is a term using only whole number exponents. And those are on the variables. That's what you're looking for, whole number exponents on the variables with no variables in the denominator. Okay, expanding from that, a polynomial is a monomial or any sum or difference of monomial terms put together, because poly means many. Then we have a specific type of polynomial besides a monomial. Monomial is 1. Binomial means a polynomial with 2 terms. It's our prefix bi. And then a trinomial would be a polynomial with 3 terms. Different parts of a polynomial. The degree of a polynomial is the largest sum of the exponents occurring on the variables of any one term. We'll have a couple of examples of that here in just a minute. And then standard form is when you write the terms of a polynomial in descending order of the degree. So the degree is important. Oops, I forgot my M on sum. So it's important to know the degree so you can put the terms in order from highest degree term to the lowest. So we have descending order. And we're beginning with the highest degree term first. Now the leading coefficient is the coefficient of the highest degree term. Okay, so for these examples, what we're going to do is we're going to classify each of them as a monomial, binomial, trinomial, polynomial, or non-polynomial. So a non-polynomial, we need to state why it is a non-polynomial. Second part, write in standard form. C, state its degree. And D, name the leading coefficient. So first of all, let's look at example 11. And we need to look at how many terms we have. Terms are separated by plus or minus signs. So we have 1 is a term, negative 6y is a term, negative 5y cubed is a term, and 4y squared is a term. So we have 4 terms, so we're going to classify that as a polynomial. Because we have 4 terms. Okay, since it is a polynomial, we're going to put it in standard form. So we need to look at the exponents. Well, the exponent on 1, this is actually 1x to the 0 power. 0 is a whole number, so that qualifies. We have negative 6y, that's to the first power, so that's a whole number. Then we have 3 as an exponent and 2 as an exponent. So we're going to start with the highest one first. That gives us negative 5y cubed plus 4y squared minus 6y plus 1. C, state its degree. Well, the highest exponent is on our first term, which is 3. So the degree is 3. And then our last question, what is the leading coefficient? Well, the leading coefficient is negative 5. It's the coefficient of the highest degree term. Okay, let's take a look at example 12. Again, we have a bunch of different terms. So we have negative 2x cubed, negative 5y to the 1/2, and a positive 3/4 y to the negative 8th. Well, look at the exponents. Do we have all whole numbers? Well, if we look, 3 is a whole number. That's good. Is 1/2 a whole number? No, it's not. It's a fraction. So this makes it a non-polynomial. So we're going to answer A as non-polynomial. And we also have to state why, and that's because we have not all whole number exponents. Okay, and then we don't have to answer B, C, or D. Now, if we also look back at number 12, we have an exponent of -8. -8 is also not a whole number. Remember, whole numbers are 0, 1, 2, 3, 4, 5, etc. So both of those disqualified as a polynomial. Example 13, we take a look at that. Do we have all whole number exponents? Looks like we do. How many terms do we have? There are 3, so that makes us a trinomial, as we have 3 terms. Second question, write it in standard form. Well, we have to figure out what the degree of the terms are. Remember, the degree is the sum of the exponents on the variables. So if we look at our first term, we have an exponent of 3 on a variable, and this is y to the first. So the sum of those exponents gives us a degree of 4 for this term. Next term, we have x to the first, y to the second, so our degree here is 3. And then our last term, we have a squared and a cubed on our variables, so that gives us a degree of 5. Then we can easily put those in order. We have x squared, y cubed, because that's the highest degree term together, plus 4x cubed y minus 3xy squared. So what is the degree of our trinomial? Well, it's to the 5th degree. So we have 2 plus 3. And then D, what is our leading coefficient? Well, the coefficient of that term is 1. Okay, adding and subtracting polynomials, it's just combining like terms. You just have to remember with the negative that you need to distribute the negative to the polynomial in the parentheses. So our first example is addition. We're just combining like terms. So we have 5x cubed and we have x cubed. Those are alike. That is going to give us our first term of 6x cubed. Oops, sorry about that. 6x cubed. And then we have our squared terms, negative 7x squared plus 2x squared, which gives us a negative 5x squared. Our next term would be a negative x. There are no other like terms. And finally, we have a negative 3 and a plus 8. Those are like, so we end up with a plus 5. Okay, 15 is one of our subtraction problems, so we need to remember to distribute this negative to each term inside the parentheses. A lot of times I like to rewrite this out and then combine like terms, so that's how I'm going to show you how to do it. So we have 7y to the 4th minus y squared minus 4y plus 2. And then we have a negative 3y to the 4th. A negative times a negative becomes a positive 4y squared. And then we have a negative times a positive, or we're just switching the sign. That's going to give us a negative 3y. It's a negative right there. Okay, then we just combine like terms. You have a 7y to the 4th and a negative 3y to the 4th. So that's 4y to the 4th. We have a negative y squared and a positive 4y squared. So that gives us a positive 3y squared. Negative 4y and a negative 3y gives us negative 7y, and then plus 2. And there's our final answer. So addition and subtraction are easy. With the subtraction, you just need to remember to distribute the negative to everything in the parentheses, not just the first term. Okay, multiplying binomials. It's a distribution method. You're used to it as FOIL, but really what you're doing is you're doing a distribution of the terms in the first binomial. Here we have two terms, 2x minus 1, that's a binomial. 3x plus 2, two terms, that's also a binomial. Here's what it would be in terms of FOIL. First, outer, inner, and then last. Oops. Just correct that there, last. Now if you think about this as a distribution, what you are doing is you are distributing 2x to the binomial 3x plus 2. And then you are distributing a -1 to that same binomial 3x plus 2. So you can think of this as a double distribution. And I write it this way because in the next section we're going to be factoring, and it's going to help us when we're factoring by grouping to see this as the reverse process of the distribution process, the expanding. Okay, so once you distribute the 2x times 3x is 6x squared, 2x times 2 is 4x, -1 times 3x is -3x, -1 times 2 gives us -2. We combine the two terms in the middle because they are alike, and we end up with a trinomial that's listed. Okay, let's try a couple of these out in our examples. It says find the indicated product, write in standard form. Here we just have a simple distribution because we just have one term times a binomial, so we're just going to multiply those and distribute the 8y cubed, and we end up with 16y to the 5th, so we have to remember our exponent rules, y to the 3rd times y squared. When we multiply powers of the same base, we add the exponents. 3 plus 2 gives us 5. And then if we distribute the 8y cubed to the -6y, we end up with -48y to the 4th. Okay. Example 17, a binomial times a binomial. I'm going to show you with the distribution method, which is the same as FOIL, but I'm going to show that step. So we're going to distribute the 3x to the binomial 5x plus 7. And then we are going to distribute the -2, which is the second term in the first binomial, to 5x plus 7. So when we do that, we end up with 15x squared plus 21x minus 10x minus 14. Combine like terms, and our final answer is the trinomial 15x squared plus 11x minus 14. Okay, then we have some special products that we want to show you, just a few shortcuts. If you have a binomial conjugate, meaning if you have a binomial a plus b, its conjugate is a minus b. We're going to be using that a lot. And when we multiply those together, I'll show you just using our standard process of FOIL or our distribution, we end up with a squared minus ab plus ab minus b squared. But you'll see that the two terms in the middle cancel each other out, a negative ab and a positive ab. So that just simplifies to a squared minus, sorry about the writing the plus, minus b squared. So this is just a shortcut. If you see a binomial times its conjugate, you can take the shortcut in as a squared minus b squared. Two other quick shortcuts. Binomial squares. So if you're taking a binomial and multiplying it by itself, it is not just a squared plus or minus b squared. That's what people tend to do, but you're missing that middle term. This does not work. Here is what we end up with is a squared plus 2ab plus b squared. If it's a difference of terms squared, you end up with a squared minus 2ab plus b squared. Those will just make some of the problems a little easier to solve. So if we take a look at some examples, example 18, you'll notice that this is one of those special types. It's 3x plus 4 times 3x minus 4. This is our binomial conjugate. So we know our shortcut is just a squared minus b squared. Well, if we look at this, a is equal to 3x and b is equal to 4. So if we put it in the form of a squared minus b squared, that's going to be 3x in parentheses squared minus 4 in parentheses squared. 3x squared is equal to 9x squared minus 4 squared, which is 16. So if you know those special products, it makes the problem really quick and easy. If we take a look at number 19, that's a binomial square of a sum. And a is equal to y, and b is equal to 3. So if we look at that form, it's going to be y squared plus 2 times y times 3 plus 3 squared. You see I'm just taking this form right here and substituting in, and when you substitute, it's always a good idea to use parentheses so you keep everything clear. And then we're just going to simplify. Y squared is y squared. 2 times y times 3, that's a plus 6y. And then 3 squared is 9. So there is our answer. This is also known as a perfect square trinomial. Again, we'll hit those things a little bit later. You'll see that a lot. And then example number 20, this is the difference of squares binomial. So we look at our form that we have up there. We know a is equal to 3x, b is equal to 2. Okay, it's not negative 2. We look at the form, it's a minus b. The minus is already there, so the b value is just 2. We substitute into that form, we end up with 3x in parentheses squared minus 2 times 3x times 2 plus 2 squared, and then we multiply everything together. We end up with 9x squared minus 12x plus 4.